So we've got x squared plus y squared equals r squared. What about that 2x? You can't stare at it. You got to look over there and say, what could I, how do I get rid of an x? Yeah, x is what? R cosine of theta, right? So r, I could put 2 times r cosine of theta. Good. So now, do I have everything gone? X's and Y's, are they gone? Yeah, I don't see X's and Y's. I just see R's and theta. So I've actually got this in polar form right now. But I did write you a quick note. Would you please do this in your assignment to solve for what? R. Get it to say R, not R squared. So what could you do? You got an R over there. You got R squared over here. What could I do to make it R? Just R. Square root. Well, if I took the square root of this, yeah, I get the R, but I'd also get plus or minus R. And if I took the square root of this, how do I take the square root of R? I still got R over there. Close. I mean, good guess. Well, I've got an R on the right, and I've got 2 R's on the left. Yeah, you could use division to help you. And if you want to get rid of that R, divide it by R, right? The R's are gone. Divide this R by this R squared by R. What would you get? R. There you go. R equals what? 2 times cosine of theta. Okay. Now, you guys, the neat thing about this is when you do put things in polar form, we eventually will graph this. And the graphing comes Friday in 2 more days. But you guys all know how to graph 2 cosine of theta. Well, you did in November. I don't know if you really know now. And you did it on Monday's assignment. But this is where we're going on Friday. Okay, we're going to graph that. But for right now, no. Okay? Come on over. What do you want to do? X equals 3. Trying to get out of your way. That X, you got to get rid of it. Okay, so Sadie says, here's X, there's X. What does X equal? R cosine. Okay. So let's get rid of X and go R cosine of theta equals 3. Solve for R. What do you want to do? Say it again. Okay. Sadie's doing all the talking. Everybody agree with this? Divide by cosine?
You're going to have to agree.
You're going to have to agree? That's good. Cosine of theta. Divide by cosine of theta. Knock out the cosines. R equals 3 over what? Cosine of theta. Now, hang on. You know what? If I asked you to graph something like this, you wouldn't want to graph 3 over cosine. So we want to clean it up using maybe our identities we used way back in chapter whatever, 5. Do you realize that 3 over cosine is the same as 3 times 1 over cosine? Right? Because 3 times 1 is 3, and cosine on the bottom. But what's 1 over cosine? It's secant. Yeah. So this is using your reciprocal identities back in chapter 5. So really the final answer would be 3 secant of theta. And that's the easiest equation for you to graph on Friday. Although I will tell you this, we're not graphing any secants, don't worry. But this is where we're going. We're going to be graphing this. This is what we'll graph on Friday. We won't graph these. Okay? But always solve for R and try to make it so you don't have fractions. And this is about as difficult as it gets in your assignment. Okay? Cool? Okay. Are you okay with rectangular to polar? Well, what's next? Polar to rectangle. Okay. So here we go. Polar to rectangle. Convert this equation, r equals 2, from polar, r theta, to rectangular, xy, then determine what type of graph it would produce. So in this version, they actually say, what kind of graph is this? And you'll see in a second. Okay? Okay, so we got r equals 2. I'm waiting. Wait, you. R. Can't have r's. Get rid of it. This is what you're looking at on your own slides, right? Say again. Plug the 2 into the r squared. R equals 2. She's saying put the 2 in here, square it, and get what? 4. This equals 4. I've never done it that way. Never done it that way. That's good. That's really good. Yeah, that was really good. But here's the deal. Sometimes when I look at this stuff, I go, r squared is this, correct? Okay. How could I make that an r squared over there? If I did what? Squared it, okay. So if I squared this, then I have to square this, correct? What you do to one side, you got to do the other. Then you get r squared equals what? 4, but what's r squared? Looking over there. X squared plus y squared, right? Equals 4. Okay. See, your way might have been a little quicker, but this is me trying to make this look like my conversions over there. So if I squared the left side, the right side, I get this, and r squared is x squared plus y squared equals 4. Then it says, then determine what? What type of graph is this? Peyton says it's a circle. An x squared plus a y squared, you just finished chapter 10, 1, 2, 3, 4. It almost looks elliptical, but why are you calling it a circle? Coefficients 1 and 1. We said that. If the coefficients are the same on x squared, y squared, it's a circle. And it is. Do you guys remember way back in the beginning of the year when we said we have x squared plus y squared equals 4? What's the radius of this? Yeah, the radius is 2. This is actually over here. The formula said equals r squared, so your radius is 2. You guys should make a quick sketch of that. What would this look like? Where would the center of the circle be? Yeah, 0, 0. There's no x minus 2s or y minus 3s. And then the radius is what? 2. Up 2, down 2. Left 2. So you basically have this look. Good? That's it. It's a circle. R equals 2. Hey, when you think polar, guys, think polar. If this was the polar axis, okay, what does a radius of 2 look like? Well, a radius of 2 means from the pole, go where? 2 up, right there. Where else do you have a radius of 2? Here, here, here. So if they tell you the radius is 2 and that's all they tell you, well, that's what you have. You have a circle with radius 2. That's another way to look at it. Okay, you can look at the rectangular coordinates, or you can just look at the polar coordinates and kind of think it out. Okay? How about this one? Theta equals pi over 4. Change what? Oh. So she says that theta, she says I can just take tangent of theta. Right? But if you take tangent of theta like she did, I mean, I'll do what Sadie did. But Sadie, you took tangent on the left side. Now what? Don't you have to do it to the right side? You can't just say, I'm going to take tangent of theta and call it quits. You'd have to do this too, wouldn't you? theta tangent of pi over 4. Now what is tangent of theta? Just y over x. There you go. Once you get it to look like that, you know it's just y over x. So y over x equals tangent of pi over 4. Do we know that one? Yeah, I think we know it. It's 1. It's 1 square root of 2. It's just 1. Good? What is that graph? Is that a circle? It's a line. If you actually solved it, multiplied by x on both sides, you get y equals 1x or just x. And it's a line, you're right. So if I do a quick sketch of this one, y-intercept 0, slope of what? Up 1, right 1, up 1, right 1, and keep going. Keep going. There you go. It's a line. So this was a circle. This is a line with slope of what? 1. Okay? Hey, if you think about it, guys, did that say theta equals what? What did it say? Theta equals, wasn't it pi over 4? Wasn't that what it was? Yep. Okay, in polar, if you think about polar, it's basically telling you theta must be pi over 4. So if you said radius 1, where would you go? Pi over 4. If you said radius 2, where would you go? Pi over 4. Pi over 4. You just keep going pi over 4, and you get these dots, which forms a line. It's a line. You can think about it in a polar way and see that it's a line. But when you go to rectangular, you know it's a line because y equals x. Okay, last one. See what you can do. Just try it. Give it a minute. Get that to look something like those. That's, I know why you did that because of the first problem. And it got messy. And then you went, oh, I'll show you a quicker way to do this. So, I saw that r, and I knew what? I knew r squared was x squared plus y squared. So if I can make that r squared, I'm gonna like it. How'd you do it? Mason, how'd you do it?
I mean, I could have just squared both sides, but I did the square root of x squared plus y squared.
Okay, so Mason said, I'm not going to make that x squared, I'm just going to change this to x squared plus y squared, square root of it, because that's what r really is. Okay, and then he set it equal to this. Is that right, Mason? Okay, and then, now what'd you do? And he squared both sides, and he got x squared plus y squared. So he does this, okay, and he gets now 4, and then he gets sine squared. Whoops. 4 sine squared. No, he's doing much more. No, now he's getting stuck, and he's going, oh shoot, what do I do? So sometimes you'll do something, it won't work, or just you get stuck. That's one thing he could have done, but did you try something different? Mandy, did you try something different?
I substituted sine and theta with y over
Okay. Sine theta was y over what?
r.
R. Okay, where is she getting that from? Right here. She's saying sine of theta is just y divided by r. So she's going with that direction. And then what here?
I multiplied by r.
Oh, you
No,
left
yeah,
this.
yeah.
Oh, you left it. Okay, she left r alone. And then she says, well, if I go like this times r, r's are out. Now she gets what? R squared equals 2y, right? And then r squared is really just what? X squared plus y squared equals 2y. And are the r's gone? Mm-hmm. The r's are gone. And the thetas are gone. So we've got it. The question becomes this. What is it? Is it a circle? Is it an ellipse? Is it hyperbola? Is it what? Just like the last problem, the coefficient is 1. The coefficient is 1. What is it? Circle. Okay, here's the problem though. If you actually graph it, you'd have to complete the square. So you probably bring the 2y over. Thank you. Put 0 there. And you just complete the square on the y's. Okay? So on the y's, what's half of negative 2 squared?
1.
Okay. Half of negative 2 is negative 1. Square the negative 1, you get what? 1. Okay, equals 0. So now you've made this perfect trinomial. X squared plus what? Factor this. 1 minus 1 squared equals. Oh, did I forget? Yes, add 1. Add 1, which makes this what? 1. Okay. Now, if I did a quick sketch of that, where is the center of my circle? 0, negative, up 1, sorry, you're right. Right there. And then what's the radius? I have a 1 here. Remember, this is r squared. So it's 1. The radius is 1. Up to 2, down to 0, right, left. It's a circle positioned about right there. And that's it. Now, you know what, Mandy, I didn't do it that way. That's not the way I did it. But the way she did it, I mean, it works. It works just fine. I got to tell you, I want to just make sure you understand. This is what I did. I actually multiplied both sides right away by r. So I took this side, and I multiplied by r. And then I took this side, and I multiplied by r to give myself what? R squared equals 2r sine, which ends up being, yeah, x squared plus y squared for r squared, 2y. So I got my equation that way. Mandy got her equation this way. Mason tried it, and he ran into a roadblock. So when you run into the roadblock, you back up, and you just say, well, let's try something different. I just need somehow to get, it was really important for me to get that r squared. It was really important for Mandy to get it, and she got it. But once you get the r squared, you just replace it with that. Okay? That's all I have. I did cut the assignment down, as you see. These last 3, these are basically you doing this, and you tell me if it's a line, a circle, or whatever you think it is. Okay? So 11:05, and I think we have 10 minutes. Okay, you know what? Let's just jump in. Let's do something. Pick a number between 65 and 73.
65.
60 what?
7.
67. Do it. Go. 67. Go do it right now. Is it y equals 4? Right?
What do you need to do to make a portion of that test? What do I need to do to make that test?
Oh, well, well, since you don't have much to talk about, if you just showed up, let's go over some. We just want to talk about where you're missing, and if you want practice, you got a whole time to come back next week. If you feel like, no, I just kind of still take it. It's up to you. But
I'm assuming tonight probably.
why not? Oh, after the deadline. You can come. Where it's not like I hire you. I'm not a student. Yeah, you can come. After school. A couple things to hand out, guys. So.
This says too many names. Too many sheets.
Okay, I think we're going to Polar, aren't we?
So again,
Cole, what'd you do on this one?
I just started.
Didn't even start. Okay, Peyton, what'd you do? Yep.
I put 4 equal to r times sin.
Okay. So this is what Peyton did. She saw y. She wants to get rid of y. It says right here, y equals r sine. Oh, she replaces it with r times sine equals 4. But remember in my slide I said, in these kind of problems, would you please solve for r? So now, Peyton, what do you do?
I did divide by sin theta on both sides.
Divide by sine and theta on both sides. Okay. And canceled out sine and theta. Got r equals 4 over sine of theta. Okay. Here's the deal. I understand the x's and y's are gone. But you, on Friday, will be graphing this stuff. We don't want to graph fractions that have trig functions in it. So can we somehow change this over to what? 4 times cosecant of theta. How did she get that? Well, 4 over sine is the same as 4 times 1 over sine of theta. And 1 over sine of theta is cosecant of theta. So that's how she went from there to there. Okay? I think, right? Okay, so we picked one in the first section, pick another one, 85 to 97. Yeah, we pick one. I don't care, I want somebody to pick one. 90, do not. 91.
Oh, I'm not kidding. Yeah, sure, yeah,
Three.
sure, go right ahead.
91. Go to 91, guys. Get rid of r's and thetas, make it x and y. Okay, it's hard to get rid of theta. You gotta make theta look like Well, if you want it to be x's and y's, yeah, you need, if you get theta to be tangent of theta, you can just call it y over x. Well, what do you do? What do you do to both sides? Say again. Well, I'd take tangent on the left side, and then I'd probably jump to the right side and do what? Tangent on the right side. Whatever you do to one side, do to the other side, right? Well, tangent of theta, looking over here, is the same as y over x. Hey, theta's gone. I got y's and x's. This one, what's 11/6 pi? 330, you're right. So it's basically it's right there, which creates this triangle. This is a what? Reference angle? 30. This is -1. This is 2. This is square root of 3. What's tangent? Okay, so he says -1 over the square root of 3, but that's what? Negative square root of 3 over 3. Okay? You know, when you got x to the first and y to the first, this is going to be a y. A line. It's linear. It's x to the first, y to the first. It's a line. I'd solve it for y. And maybe just, here I cross multiply, I get 3y. I get x times that. Well, that would be this. And then y equals what? Negative square root of 3 over 3 x. It's a line. What's the slope in this line, by the way? Yeah, negative square root of 3 over 3, exactly.
Did you do 73?
Is that the last one? I'd kind of like you to monkey with it. Just try to get it yourself. Yeah. Okay. Anyways, that is the lesson 10.7, and tomorrow we'll just repeat it with a worksheet, and then we'll finish the class with probably a 15-minute quiz on just 10.7. That's it. Okay. 3 times x. Look up there. See on the left side. What does that do? Yeah. So don't write 3 times x. Write 3 times. Now, you could nuke. This is a kind of dumb one, but you have to solve it for r. Because really, all you guys know is first things first, you have to square this, and you can't just square this and solve it. You have to move this one over. Well, the only problem is then you have -2 over r. You know what I mean?
Think about using the cosine.
Just write it down. Set that down.
Or sine data and r sine data. That might be easier than trying to get x squared plus y squared.
No, I said you said divide by r. If you did something that's very, very common in all of us, is autism. Because it's the GCF. Well, it's part of this 3 r cosine. It's yeah. Now see this one, when it's 2 over cosine, it's easy to call it secant, but it's not just cosine, it's cosine.
Let's just work on this.
This is the only way Travis, you coming in tonight? Okay. Hey, retakes. It's Friday's getting close. We need to kind of come in and get some help, and then let's do it. Okay? I know of 2, maybe 3 people in here that have already said I want to do it. You want to join the club? Join the club, but you only have a couple more nights. Oh, you didn't even take, right?
No. Gotta take it. Club.
You're in that club.
Pretty exclusive.
Yeah, you're right.
Hunter, silver. Yeah. No, we're at a hockey tournament.
You know, I had it and I lost it. Here's what
This is just for grinding out there. Academic pep rally.
Well, you need.
That's just for today. They
Yeah.
got it.
They saw me grinding the young classes and
Oh, yeah, this guy's
What's that?
This hour is 11:45 to 12:30.
No, yeah, you went.
No, I have.
To what?
12:30.
You already got it. Next, 6,
12:35 to 1:15.
35. To what? 1:15?
Yep.
Okay, next.
1:20 to
1:20 to 2. Got it.
2:05.
Which one? Great.
Mr. Baker,
Yes.
can I get the worksheet tomorrow since I'm gonna be gone?
Yes, you can.
So choose the pep rally?
Yeah.
Okay.
We just shave, and then they get the whole 7 hour off.
Yeah.
Alright.
You don't have 7 hours?
Well, we have 7, but the, the normal 7th hour is 2 to 3 o'clock.
Yeah,
Oh, we've shaved enough, maybe that's all free today.
but we still have 7 hours.
Yes, you do. It's right there. 1:20 to 2 o'clock. Is 7. Hang on. You know, I gotta tell you something. It's convert only range to rectangular, but there's no rectangular board. I might add just a couple more in that. So, could you check in with me in the morning, or are you not here all day
I'm gonna be here
until?
second period.
And that's Amy. Agree?
Yeah.
Yeah, just if you can check in, I'll try to get them changed, even tonight after school.
Okay, sounds good.
And that's what we were doing right